Balanced forces. The famous English scientist Sir Isaac Newton, who lived between the 17th and 18th century, devised three laws of motion. The first law states that if all the forces acting on an object are balanced, there will be no acceleration, meaning either constant velocity or the object remaining stationary. But what do we mean by balanced forces? Let's look at the example of a horse. The first force we will consider is the force of gravity. This acts towards the centre of the earth. The size of the force of gravity is the horse's weight. An arrow is drawn downwards from the horse towards the centre of the earth. If this were the only force acting on the horse, it would sink into the ground. As this is not the case, there must be a force opposing the force of gravity. An arrow is drawn in the opposite direction, but equal in size. This force is called the reaction force. As the reaction force is the same size, but acts in the opposite direction to the horse's weight, these two forces are a balanced pair of forces. There are other forces acting on the horse. The horse is moving forward, and therefore there must be a driving force from the horse's legs. The driving force, though, is opposed by forces trying to slow the horse down, and if the horse is travelling at a constant velocity, the force of friction and air resistance are equal in size but opposite in direction to the driving force. The driving force is now balanced by friction and air resistance, a balanced pair of forces, and the horse now travels at a constant velocity. If though the horse accelerates, the driving force must be greater than friction and air resistance. The driving force is now no longer balanced by friction and air resistance. These forces are now unbalanced. So in summary, when the forces are balanced on an object, the object will either remain stationary or travel at a constant velocity. When the forces are unbalanced, the object will either accelerate, meaning an increasing velocity, or decelerate, meaning a decreasing velocity.